Good afternoon, ladies and gentlemen. Welcome to the 10th India-Taiwan Cooperation and Friendship Forum, co-organized by the Taipei Computer Association and Foundation for Commerce and Culture Interchange. We would like to first thank our speakers for taking the time to be with us, and we kindly request you to keep your cameras on the whole time. To begin our program today, please welcome Dr. Leo Lee, Executive Director of the International Cooperation Office of the Taipei Computer Association, to offer his welcoming remarks. Let's welcome Dr. Leo Lee.
Welcome, everyone. This is Leo Lee, CEO of ITCF. Thank you for joining us in the 10th Annual India-Taiwan Cooperation and Friendship Forum. It's been our great pleasure to have played a very tiny part in the growing India-Taiwan cooperation on the past decade. Our topic this year is Silicon Handshake, forming technology alliance post-pandemic. Thank you for joining us today. I would like to first acknowledge our fellow organizer and supporting organizations. First, I would like to thank Ms. Cynthia Zhang Zhang, Director General of the BOFT, for offering support and her remarks. Then we have our friends from India-Taipei Association, Mr. Wen-Kuan Yeh. The ITA is one of our best partners to our India-Taiwan events, as they have a long-standing partner for the first ITCF. We also thanks to the Taipei Economic and Cultural Center in India for their recommendation of many speakers here today. And the moderator of today's panel discussion is the Dr. Dennis Hu, President of FCCI, my old friend. Thank you, Dennis. Finally, I would like to thank our speakers, include Dr. V.K. Saraswat, Dr. Wen-Kuan Yeh, Mr. Raji Kushu, Dr. Zheng Kaian, Dr. Ashutosh Sharma, Mr. Shaula Gore, and Mr. K. Kashina Moti, and Ms. Ritovana Mendo, and of course the Mr. Lin Zhiming, Frankwell Lin. The topic of our discussion today is very important. The shortage of semiconductors has become a very, very well-known and important issue this year. It causing disruption in many important industries across the world. So we are very much delighted and honored to have those experts from their respective field join us to share their valuable view today. I want to thank everyone again, and we look forward to have a very informative and fruitful discussion and result. Thank you.
Thank you very much, Dr. Lee. Next, we have a pre-recorded remark by Ms. Cynthia Zhang, the Director General of the Bureau of Foreign Trade, the supervising organization of the forum. Let's welcome Ms. Zhang.
Ladies and gentlemen, good afternoon. I'm very pleased to attend the 2021 India-Taiwan Cooperation Forum, organized by the Taipei Computer Association. And despite the pandemic, I still see so many industry representatives and academics attending today's forum. This shows the eagerness from both sides to strengthen cooperation. We all know that India is a very important country in the region. With the population of 1.4 billion, India has the advantage of big market scale. And the average age of the population is only 29 years old. And I think that this will lead to dynamic economic growth. Taiwan and India enjoy very close trade and investment relationship. Many of our ICT companies have establishment in India, such as Foxconn, Winstron, Pegatron, etc., thereby forming industry clusters. And recently, they have been approved as corporations under the PLI schemes, which means that they will increase production and thereby providing more job opportunities. As to trade, India is Taiwan's 17th largest trading partner, and we are complementary to each other. We export IC and chemicals to India while we import raw materials to India. Despite the pandemic, our bilateral trade still increased. For the first 6 months of 2021, our bilateral trade has increased 70%, 70%, and this is really amazing. In terms of industrial development, India has the advantage of talent pool. I was really amazed to know that 500,000 engineers graduate from college every year in India, and this has attracted many semiconductor companies such as Intel, TI, to set up R&D centers in India. Other than that, many talents have returned to India from Silicon Valley, and I think this is really promising. While on the other hand, as to Taiwan, we have followed a different path for our semiconductor development. We focus more on manufacturing with our OEM production capabilities and also a complete supply chain. We are able to distinguish ourselves and also occupy a very important role in the global semiconductor supply chain. But however, if we speak about supply chain, India has actively developing autonomous supply chain, and it is also a core member of the SCRI, the Supply Chain Resilience Initiative, and also of the Quadrilateral Security Dialogue, while at the same time, Taiwan holds a very important strategic position in the Indo-Pacific region. So I think bilateral cooperation will definitely beneficial to both of us and bring win-win outcome. Lastly, I wish today's forum a success and good health and prosperity to everyone. Thank you very much.
Thank you very much, Ms. Zhang, for the welcoming remarks. Next, let's welcome Mr. Guan Das, the Director General of the India-Taipei Association, to deliver his VIP remarks. Mr. Das, you have the floor.
Thank you and namaste. Dr. V.K. Saraswat, member of the NITI Aayog, my good friends from the Taipei Computer Association, Dr. Lee and Dr. Hu, the participants and the speakers of today's panels. First of all, I would like to thank the Taipei Computer Association, as well as the other partners like the Foundation of Commerce and Culture Interchange and the Bureau of Foreign Trade from the Ministry of Economic Affairs in Taiwan for taking the initiative today to hold this forum in online format. I congratulate the organizers on completing the 10th anniversary of the forum. You have held this milestone event every year uninterruptedly for the last 9 years, which speaks to the commitment and trust in India-Taiwan partnership in the fascinating field of information technology. And we from the ITA, the India-Taipei Association, have been privileged to have you as our partner in this effort. In the last 10 years, the ITCF, it has emerged as a premier platform and as a bridge, bringing together the policymakers, industry, and academia of both India and Taiwan to explore collaboration in various aspects of IT. This forum has been ahead of the curve in identifying new areas like smart cities, AI, IoT, which you have taken as a theme of your earlier meetings. And you have taken these as areas of technology cooperation between India and Taiwan. And it has also resulted in concrete cooperation. India and Taiwan both have very significant digital economy, both built with indigenous effort, with visionary policy and creativity of our two peoples. The digital economy has powered recent growth in both our economies. But in the past, the digital economy and the digital ecosystem in India and in Taiwan have developed in parallel along two separate trajectories. India, as DG Chiang was mentioning a little while back, has developed a robust software-based ICT industry on the strength of its higher education and the research sector, while Taiwan has capitalized on its manufacturing prowess to establish world-class ICT hardware, including in the field of semiconductors, which is, of course, today's main area of discussion. But before I get to that, I would like to recall that in the past, the collaboration between the two ends of the IT spectrum was possible, but not necessarily vital to the development of the industry in either India or in Taiwan. The last couple of years have changed all of that. Just to recall a few factors. First, the emergence of new technologies have transformed the digital landscape. AI, IoT, smart cities, 5G, new energy, digital transformation of the industry, you name it. All of them require a complete integration of hardware and software. This inherent convergence of emerging technologies create the possibility to leverage the excellence of Taiwan's hardware and the strength and affordability of India's software to help each side stay ahead in this game. Second of all, as part of the effort by the government of India to boost the domestic manufacturing, we are also taking a number of proactive steps to attract the ICT manufacturing into India. And as everybody knows, Taiwan is the top global player in the ICT supply chains, particularly in the EMS sector. And therefore, Taiwan is also a top target for our government to attract foreign investment in this sector. There are already many pioneers and many success stories, some of which were mentioned by DG Chiang in her presentations. But we hope that many more will come forward with effort from friends in the Taipei Computer Association. The third factor, this new trend has been further accelerated by the experience of COVID-19, which dramatically boosted the demand for digital products, accelerating the digital transformation. The pandemic also underlined the need for more resilient supply chains of critical products, among which digital products are, of course, the foremost. The government of India has come up with production-linked incentives in many sectors which create additional opportunities and additional incentives, additional attractions for the Taiwan's ICT industry to move into India. And fourth, the digital transformation anywhere requires a large number of high-skilled manpower. As Taiwan is experiencing a demographic decline and a trend of aging, Taiwan's industries could tap India's young and creative manpower to power the next phase of their growth story. So with all of this, I am quite confident that going forward, our cooperation, India-Taiwan cooperation in the ICT field will deepen much more and accelerate much more than it has done in the past. Forums like the ITCF and organizations like the TCA will have an even more arduous task to carry on their shoulders in the future. So I'm also quite happy to note that today's theme that the ITCF has chosen is Silicon Handshake and new technology alliances post-pandemic. This is a topic under which I believe the focus will be on the semiconductors. This is one area where we have not really gone into depth to explore cooperation with Taiwan, but I think time is now ripe, because as manufacturing of ICT in India intensifies, we have ambition to create more upstream segments of the industry in India. Certain capacities in this regard are imperative, not just from the point of economic security, but also from the point of national security. So our efforts in this regard are very, very serious, very, very sincere. And we hope that we can find good Indian and Taiwan industries to come together to explore real possibilities of cooperation in this regard. So I hope and I'm confident that today's discussion by such eminent panelists will bring out our convergences and our interest much more clearly. And I look forward to your recommendations in this regard. Thank you once again for doing this event today, despite all the challenges of the pandemic. And I wish you all the success. Thank you so much.
Thank you very much, Mr. Dust, for your remarks and your analysis. So this concludes our remarks. Before we dive into the keynotes, we would like to invite all our speakers and our panelists to take a quick group photo together. Please make sure your video is now on and smile when I count down to 1. Let's just take a second to make sure everyone's video is now on. So Dr. Zheng Kai An, Mr. Frank-Well Lin, you guys could turn on your video. All speakers, so don't be shy. Okay, so I think that's everyone. So when I count down to 1, please smile at your camera. So 3, 2, 1. Keep smiling. Make sure we get your beautiful smile. Thank you very much. And for the next one, please put your thumbs up. And I'll count down to 1 again. Okay, so 3, 2, 1. Thank you. Make sure you keep your thumbs up. Perfect. Thank you all very much. I really appreciate your patience. And now, let's begin our keynote speeches. It is an honor for us to have the following experts in today's forum to share their valuable insights and observations. First, let's welcome the keynote speaker from India, Dr. V.K. Saraswat, the member of India think tank Niti Aayog and Padma Bhushan Medal recipient. Dr. Saraswat is a highly accomplished researcher, having led Indian advancements in both the military and civilian sectors. He will give us a speech on research and innovation, key to a self-reliant economy. Welcome, Dr. Saraswat.
Very good morning. I hope I'm audible.
Yes, sir. Very clear.
It's indeed an honor and privilege, and I'm very happy to participate in the deliberations of the 10th Indian-Taiwan Cooperation and Friendship Forum. The focus of this forum today, being Silicon, is most relevant in the changing global scenario as far as the requirement of electronics post-pandemic is concerned. I'm going to talk to you today basically on how India is shaping and what we would like to do in this particular segment. And certainly we also want to make sure that whatever we can do in collaboration with Taiwan should be one of our highlights of today's discussion. So if you look at R&D, which is the engine of growth, R&D is fundamental. It is a building block to a strong innovation system. And R&D and innovation landscape is acquiring significantly different dimensions due to the evolution of 12 major disruptive technologies. I think Mr. Das also talked about it, which is basically mobile internet, automation, Internet of Things, smart systems, cloud technologies, robotics, and 3D printing, energy storage, and you know, there are many of them which are today surfacing and changing the complete R&D landscape. These disruptions are transforming the society from the society 4.0 to society 5.0 with the following features. Like the IoT will connect all people and things, all sorts of knowledge and information will be shared, and totally new value will be born. Social issues will be overcome and humans will be liberated from various types of constraints through automation. Artificial intelligence will free humans from the burdensome work of analyzing huge amounts of information. And the possibilities open to human will expand through the use of robots, automatic driving, cars, and things like that. All this is giving birth to intelligent and smart systems, making electronics and the associated software sector an important element of the smart society. This is giving rise to India's plan to accelerate digitalization by creating a robust communication, computing, and surveillance network based upon 4G, 5G, and tomorrow 6G cellular networks, internet, satellites, use of MEMS and nanotechnology. This requires a huge, robust ecosystem of semiconductor manufacturing in India. During the pandemic, Indian auto and technology sector faced severe shortage of semiconductors and other high-tech components during the supply chain disruptions. This led to a thought that setting up a domestic semiconductor manufacturing ecosystem is must to make India truly self-reliant. In the last 5 years, India's focus has been on Digital Bharat and Atmanirbhar Bharat. Today, India becomes second largest market of smartphones in the world with about 50 plus crore smartphone users, 117.4 crore mobile phone connections, and about 68.8 crores internet users. United Nations e-governance index shows India's rank climbing up to 96th position in 2018. Total number of Aadhaar registrations, which is one of the largest biometric-based digital identity, exceeds about 125.8 crores. And digital payments are led by UPI in a big way. More than 140,000 gram panchayats are connected by optical fiber network. And India today has become the second largest phone manufacturer in the world. That means we are inching and going towards what we call as the self-reliant India, in which the major focus is on 5 pillars like economy, infrastructure, system, demography, and demand. And these 5 pillars are also aiding towards India going digital for the new growth. And in part of the digital, we are looking at the following: the digital sovereignty, in which the trustful artificial intelligence empowers a strong digital supply chain, available, accessible data spaces, and cyber security. Digital for a stronger and resilient economy, where trustworthy digital solutions, platforms, blockchain, and digital identity with wider uptake across the economy, skills and talent become the primary imperative. Digital for society, and that is where the transformation of health, mobility, culture, education, and governance will be the focus. With focus on tackling disinformation and safeguarding the data will be the primary objective. Digital for planet, in which digital initiatives for greening the economy and society will be the imperative. If you look at digital intelligence, constitutes numerous technological applications to transform traditional urban infrastructure and services which includes energy, mobility, environment, social, and the workspace. And finally, all this is integrated in the form of a smart city and communication infrastructure, which will be based on servers and IoTs, mobile technologies, big data and advanced analytics, cloud computing, artificial intelligence, with a very, very significant orientation of the user and the user participation. E-health and Industry 4.0 are becoming the hallmark, which will be using the basic digitalization technology and all these disruptions which I mentioned to you. So in the light of this, why semiconductor is critical for India? Because electronics provide the solutions in terms of, for example, in terms of IoT, the sensors and the Internet of Things, the high-speed communication, the big data and computing, energy, which is the green energy for environment control and meeting the energy demand, which is ever increasing. Then, of course, we have a huge quantity of data which is being handled. So security and encryption becomes one of the imperative. Then we have, of course, security, healthcare, agriculture, pedagogy, energy and environment. So electronics is the lifeblood of present and future of any society today. In fact, there has been a statement from Sen Ben Sase, the Senate Select Committee on Intelligence, USA, who said that, to quote, modern wars are fought with semiconductors. And there is another one who, Mr. Maruf Raja, the strategic analyst of our Times of India, who said the Chinese agenda is to have access to abundance of water to manufacture microchips. So see the gentlemen, what is the kind of importance today this semiconductor, hence the silicon becomes very important. Now, what is the requirement of India? Because we have our aims as far as the semiconductors are concerned. Commercially, India imports about $400 billion US per year. The strategic import is $40 billion per year, and typically it is at the board level or system level or in terms of high value chips. The national needs which have been identified in the National Policy on Electronics in 2019 focuses on strategic needs in defense and aerospace, critical infrastructure, development of smart cities, e-commerce, banking, secure voting, solar power, power electronics, radio frequency and optical communication. Semiconductor, we have the existing infrastructure, which is basically based upon one of the core sector is the semiconductor lab in Chandigarh, where we have development of VLSI devices and development of systems for telecommunication and space sectors. This Chandigarh laboratory has facilities for fabrication of microelectronic devices up to about 180 nanometers, and it has facilities to fabricate MEMS systems. India has a very fast growing electronic system design manufacturing industry. Also, it has a strong design base with more than 120 units. We are in the process of setting up semiconductor foundry system, and there has been tremendous amount of thinking on such subject. The semiconductor laboratories, a unit owned by Indian Space Research Organization in Chandigarh, and Sitar, a unit of DRDO, each of which builds silicon chips for defense and space needs. The Indian Institute of Technology, Bombay, has a Center for Excellence in Nanoelectronics, which has a lab-like facility in collaboration with the Indian Institute of Science, Bangalore. The Indian Institute Center for Nanoscience and Engineering was established in 2010 to pursue interdisciplinary research on the nanoscale. We have a major center for supercomputing, which is called CDAT Pune. It has been entrusted with the mission of development of an indigenous design of a family of microprocessors, IPs, SOCs, and ecosystems supporting the product development to meet the India's requirement of strategic industrial and commercial sectors and supercomputers and the high performance computing systems. So India's future, what we are looking at? We are looking at different kinds of devices. It's a batik of fabrication ecosystem in which the focus is on analog and the mixed signal, digital devices, memory, flash and DRAMs, then of course MEMS and silicon carbide based systems, photonics and gallium nitride based systems, different kinds of sensors, discrete devices. So the path is basically to incentivize the MNCs and national players and to create a manufacturing infrastructure and create a strong R&D and IP and engineering talent. The R&D center is the vehicle for strategy. That is our focus. Because when we compare, China has about 170 fabs. So I think it's time that we have certain at least 2 to 3 fabs as part of this boutique. So our semiconductor focus is based on research and development. For long-term self-reliance in the semiconductor, the government is considering setting up a dedicated research institute on the similar lines of IMEC, Belgium. This institute will be research-only institute with focus on semiconductor process, new materials, sensors, and new edge technologies. It will encompass National Institute of Semiconductor and Electronics Research, also institute with focus on applied and fundamental, and probably a budget provision of the order of $1 billion over a period of $1 million over a period of 5 years. The R&D fab should aim at incorporating all the processes involved akin to a fully functional manufacturing line, perhaps discounting only on the packaging part, which can be outsourced if needed. The R&D center will have a technology collaborator identified, and that is where I think TSMC and companies from Taiwan can play a major role, so that the transition from one process to the other is seamless and in a holistic manner. The R&D activities required to be carried out in the fab will be identified, as well as products that will be produced in the fab. The R&D fab will have limited production capacity, and it is important to run it as a revenue generating model to self-sustain. The fab would be managed and run by a professional management agency rather than purely the academic institutions. The linkage between the proposed R&D fab and the various fabless foundries, which are part of the endeavor of the Ministry of Information and Technology and Electronics, have to be established, and the mechanism identified for their linkages that may be considered as translational centers for future synchronization with the main fab. The strategy would be to build a human resource for the R&D fab, which needs to be laid out, keeping in view the existing researchers in various IITs and other institutions. The major areas which are emerging today besides silicon are gallium arsenide and gallium nitride. So there will be a focus on silicon as well as on these products also. However, there will be a separate focus on setting up the ATMPs and the product development as important as part of the MIT's initiative. So in the light of all this, when we are planning to do this, there is a significant possibility of India-Taiwan partnership for driving this change. And this change can happen in 4 quadrants. Government to government, where we can implement a strategy and conditions for innovation, and also lead through the retooling of our programs. And we can bring in a marquee customer there. As far as the universities and colleges are concerned, I think there's a fairly good chance in this approach to develop curricula and skills for the innovation economy, and connect learners to business and business to the research. That could be done through our cooperation. The private sector, that means industry to industry, should be actually made to make investments in R&D and ICT adoption. Need for patient capital and local on disruption technologies, as like artificial intelligence and quantum computing and so on. And of course, there is a civil society where there will be a significant amount of benefit for both the countries. Globally, if you look at the scenario, and why I'm advocating this kind of collaboration and cooperation, is mainly because the global semiconductor market topped about $464 billion in 2020, and is expected to reach about $522 billion in 21. That will be a growth of about 12.5% as per the International Data Corporation USA. Samsung, TSMC, and Intel have collectively announced more than $130 billion for new chip foundries. TSMC plans to spend more than $100 billion over the next few years to address the capacity demand. Change in consumer buying behavior, the 5G rollout, and the move to remote work and education will lead to increase in the consumer spending. PC and server shipment has seen a strong growth in 2020, which is up by about 17.3% year over year. As Mr. Das was mentioning, India has made many provisions for incentivizing the investment in this sector. One among them is the production-linked incentive scheme, which provides customized incentives for semiconductor players. A big boost is expected for chip manufacturing and electronic component and equipment manufacturing in India. With a growth rate of almost 30%, the electronics production industry in India hopes to be about $410 billion by 2025, which will be 8.2% of the GDP as against presently about 3.2%. One of the think tanks and the consultant Frost and Sullivan reported that Indian electronic system market will grow to 2.3 times of its current size to reach $160 billion by 2025. Hence, this is the most opportune moment to set up a semiconductor fab and advanced technologies in a partnership mode for global market. To conclude, I would say a semiconductor R&D center is needed for cost-shared translation of R&D to manufacturing, for commercial and strategic products, for consistent technology and product development, initiation and leadership. That is the focus of R&D fab. Since corporate research is expensive, we must work towards research co-sharing. Government shall provide consistent cost sharing vis-a-vis startups to support them. Programs and funds for disruptive technology and incubation will also be harnessed. So the way forward is that India must emerge as the next major semiconductor chip designer and manufacturer in the world, given its strategic importance for the nation. A risk-seeking mindset of entrepreneurs and venture capitalists has to be harnessed in this area. We have to create a homegrown, fabless semiconductor design ecosystem and harnessing local talent and helping nurture academic institutions as well as startups. Taiwan can act as a technology partner in setting up a mega fab and an R&D fab, research and development institutions, and supporting the Indian ecosystem to go from the numbers what I have mentioned to what we have projected. Long-term technology development relationship with Taiwan will catalyze the economic growth in both countries. So this platform, I personally believe, should certainly be the catalyst for bringing this cooperation to a level so that India's vision for improving its semiconductor ecosystem, going to the level of $410 billion of production in the country and having a high GDP can be achieved. And that will also promote the economy of Taiwan and economy of India. So I wish good deliberations, good discussions on this platform. And finally, very happy if a roadmap can be worked out, some strategy can be worked out to bring this collaboration to the reality and fruition. Thank you very much for giving me this opportunity.
Thank you very much, Dr. Saraswat, for your keynote. Next, please welcome the keynote speaker from Taiwan, Dr. Wen-Kuan Yeh, Director General of the Taiwan Semiconductor Research Institute. Before taking on his role at the TSRI, Dr. Yeh was a seasoned semiconductor researcher at TSMC and UMC. Let's welcome him to talk about the making of a semiconductor ecosystem. Welcome, Dr. Yeh.
Ladies and gentlemen, I'm the Wen-Kuan Yeh from the TSRI. I'm very honored to join this Taiwan and India cooperative forum. I give some experience about the Taiwan IC technology development, and our center is support to cultivate the high-tech talent for the semiconductor in Taiwan. In past 30 years, we go up with the Taiwan industry for semiconductor business. This presentation, I show my PowerPoint. Okay. This is all I give some status and in the past 30 years in Taiwan and what's next for future. I think the industry revolution is always have a key the product can leverage this some kind of the technology to moving on. In parts like magnetic and power electric But after 19th century, the microelectronic have event, including the semiconductor. So moving some part of the electronic application can be made by the semiconductor IC chip. For next decade, the integrated circuit always continue to push this industry revolution, can make progress. What the future? Lot of the thinking always be made. Now we have a portable smart car and some AI application is very useful, friendly to support our life. In the future, more aggressive. You can use hand arms, just like a voice, some image sensing, and some environment sensing to sensor to test for your body. So always must link into the chip. So we looking forward the semiconductor industry will continue to make growth for next 30 years over. The transistor revolution is a long time. In 17 years ago, the transistor revolution had been made. In Taiwan, it's just not very long, just maybe in 1918 for UMC, and in 1988 for TSMC, just to be start up. You can see the 1990, near 2000, the UMC invent the first quarter micro transistor. Following the Moore's law, you can see the structure always keep, and the Intel always the leader. But for recently, you can see new application, new transistor have been made, not only by Intel, but TSMC always keep up a step after the 22 nanometer. Now, but for next, beyond the 3 nanometer, the TSMC will announce we will keep the FinFET. The Samsung will change to the nano wide. The Intel just announced yesterday in the forum, you are keeping the leadership. You are moving on for nano chip and nano ribbon. So you can see the very tough for device for more mode technology development. This is the roadmap of the TSMC. You can see not only for technology, you must change keep the mass production the time. The TSMC will continue moving the mass production for 3 nanometer in next year, quarter 2. And 3 nanometer have a different kind of solution. Even those that Intel and the Samsung continue to compete for next generation technology. You can see the past 30 years, the TSMC scaling from the 1987 start to 3,000 nanometer to next year, 3 nanometer. It's a 1,000 time was scaling in TSMC. So that's very successful for device scaling. This scaling can push application like a more smartphone, some portable application, even for the smart card, and some new electronics application can be made. That's for scaling device. What's next? This is our achievement in past year. We deliver some new material and structure for new event to replace the next generation device, including a germanium 3.5 and some new memory. New material is very difficult because it cannot replace to the silicon substrate. But you need, because silicon have the limitation, cannot cover all application. So some new application must be used new material, including the 3.5, some 2D material, some carbon nanochip. If Intel announced the next generation memory for 2 nanometer FinFET, use a gate-around FinFET like a CFET. You can see it's very difficult from the planar to vertical, like build up the multi-layer application in the one chip. For next generation application, we have 3 solutions. One is continue to scaling, but you must use the material and the new structure. Another is more and more. For new market, like sensor, like bio, like AIoT, and multiple application. And third party is how to integrate the integration. Use advanced package to integrate the memory, integrate photonic application, and some hardware and software combined to make up the very smart the system. It continue to work, but need some time. I give some example about more and more have been made in TSI. What is the next new business? The Taiwan government always created moonshot project in the past 3 years. It's for the AR/VR on demand vehicle, AI, IoT security, and the sensor and new memory. But overall, you can see the TSMC always focus on the mobile, high performance computing, automotive, and IoT. So totally, we can see that AI, big data, and connectivity is the next generation application. The TSI have a gate sensor delivered by our platform. You can see the multi-layer thin film sensor can detect CO2 and alcohol, can put into embedded in the mobile phone or some multiple application. It's very small and very efficient. Like this is the vibration inductor sensor. We use some vibration detector can detect this machine can be running smooth or not. And you will control by mobile phone, use Wi-Fi to detect it. It's very useful for security. And we also integrate the silicon wafer to the biosensor. The biosensor can put on this the microfluid, make my silicon wafer, and detect some pentagon inside and detect very efficiently compared to the chemical reaction. Some of Saraswat has mentioned is the compound application also is next for high power and high frequency. high power maybe for high efficiency, the DC to DC converter. For the charger, very efficient. Or for the smart card. High frequency is also for the LiDAR, for communication, for some smart avoid collision by the cars, very efficiency to support driver can react very quickly. So these two new material, even in China or in Europe and some in America, the Taiwan also create some program to make some possible device and application. So TCI also have this platform to support the professor can do that. So this is maybe the good topic can co-work with India. This is our very unique the sensor. It's for the satellite. We use a very smart the CMOS sensor to make by TSMC and designed by TSI. We use a very smart the array to make it very big. The CMOS sensor put on in the satellite. We will launch in the Formosa Taiwan satellite. We will launch in the 2025 and 2027. We use our homemade the CMOS sensor to put on this satellite and can resolution 1 meter square. So I know it's possible have a good topic because the space industry is very good successful in India, but Taiwan have a semiconductor technology. We can think about how to use the platform to link in the satellite to the semiconductor CMOS sensor, or use the high frequency for next generation, the Starlink, the communication, use the satellite to check this is possible. Use a semiconductor chip to replace the system. So that's a very good topic. We have continue to work. We can looking forward have some topic can meet. The Taiwan plan, maybe you want to know what Taiwan can successful. Taiwan is very successful in past 30 years because we have enough the manpower support from the Taiwan young guys. We create enough the manpower and undergraduate, and before it moving to the industry, we will train in our center, like a hands-on experience and some possible the real-time, real application training. So we have a very not any gap between the student and the engineer. No industry and academic gap. So that's why it's successful, because enough of the manpower. The growth rate always keep very good, especially in now with 15 billion US dollars. The Taiwan government always deliver the different kind of the project. Focus some of the topic, like some design, front end, back end, and SoC and heterogeneous integration. Following this company to start up. The UMC started in 1918. The TSMC started in 1987. And now this project will encourage some of the students can join before moving to the industry. So that's why it's successful. We have a very good plan, have a good company. This is the ecosystem make the student can confident before you graduate. You can very confident to learning in the university, and then very smoothly to move into the industry. That's why the Taiwan can successful, because the ecosystem is very good. The TSI is always the start the same time with the Taiwan semiconductor industry. In 1988, we started the Semiconductor Device Laboratory, NDL. And 1992, we started the Chip Implement Center. These two centers now merged in 2019 because we want to cultivate the quality, not only for verification, also have a design. So students can overall to understanding how to design and fabricate. So that for future, we can create more diversity, the capability, the young talents to support the Taiwan industry. You can see our location. We located right here. You can see the Hsinchu Thai Science Park. Just within 5, maybe just 2 miles. 2 miles. The location here, you can see the top university, Tsinghua and the Jiao Tong University, and the E3, and Taiwan Science Park, including TSMC, MediaTek, and UMC. So you get ecosystem very close. So students in here, anywhere, you understand it, what the future, just looking in the very close. So that's why the local impact, location impact will be keep this our semiconductor industry successful. So what's next? Taiwan government always have a levity plan. The Taiwan government cannot support too much the money because it's huge, the investment. But the TSMC and UMC, Wing-bound ASC, in here over the invest over 100 billion US dollar. So what's the function of the government? We needed to encourage more the young guy can involve to the industry. If we can do that, we can keep this ecosystem continue to go up, and we're looking forward for new market and new application in the 2030 and over 200 billion US dollar. So give us some conclusion. For more continue to scaling, even for the Intel, TSMC, and UMC, always continue to keep work. But for the more and more, we need some new thinking to use this semiconductor base to create some application like a smart card, like a space industry, and like some communication, or for AI. For IC system development, I think not only in Taiwan, even American, India, always want to, we need a more young guy can support to join this semiconductor development, and looking forward have a good result. We also, based on this successful, we looking forward and co-work with the industry for some new idea. Thank you.
Thank you very much, Dr. Yeh, for your keynote. Next, please welcome Mr. Rajiv Kushu, Chairperson of the India Electronics and Semiconductor Association, to make his presentation on the Indian semiconductor market analysis. Welcome, Mr. Kushu.
Thanks. Can you hear me?
Yes, sir, we can hear you.
Okay, thank you. I think thanks for the opportunity. So we have been working very closely with various stakeholders, whether it is Taiwan-based OEMs, Indian OEMs, Indian semiconductor players to ensure that this market grows exponentially, and wherever the hurdles are there, we, in collaboration with the government of India and the state governments, ensure that we are on the right track, and with a lot of focus on ease of doing business. So, and the opportunity here, particularly in the ESDM space between Taiwan and India, is really natural. I think both democracies need to leverage each other's strength. I think Dr. Saraswat talked about the demography advantage what India has, but at the same time, what is happening in India with respect to R&D, I think we are kind of increasing our focus in R&D, and Government of India is really focusing in the design-led manufacturing. So I will go through, I have a few slides. I will go through few slides, and please interrupt me wherever you feel you want some clarifications. So,
Mr. Kushi,
yeah.
perfect. Yeah, we're just making sure you're full screen the slides.
Okay.
Please go ahead.
Okay.
Thank you.
Thank you. So if you see overall market, you see electronics market is definitely sunshine market for India. It has been growing much faster than the global market. So we grew at 14% CAGR from 2016 to 2019. And it is expected to grow at a CAGR of 16.6% between 2019 and 25. And this definitely does not include the impact of PLI. So CAGR of 16.6% will actually be exceeded. And that's what we focus on. So when this report was done together with F&S, we didn't see the PLI was at a very nascent stage, and after that, with close cooperation with Government of India, we have been able to ensure that many new end equipments are brought under the ambit of PLI. So total demand, if you see, grew at a CAGR of 12.6% from 2016 to 19. It's expected to grow at a CAGR of 14.9% between 2019 to 25. What is worth mentioning here, exports are expected to grow at a CAGR of 30.8%. So this is very, very important. And this is basically years of government working in this area to ensure that the ESDM industry is getting proper attention. So if you see, India will definitely leap into top 3 countries in ESDM consumption, and it will be among the top 5 countries in electronics production. So I think with PLI, I think this is definitely going to happen in the next 5 to 10 years for sure. So in terms of the GDP contribution, today we are at around 3.4%, and it is expected to reach around 6.4% by 2025, which means that the additional employment creation will be around 1 crore, around 10 million jobs, direct and indirect. Not able to move. Okay. Sorry. Thank you. So coming to the domestic manufacturing, so domestic manufacturing grew really well from $48 billion to $81 billion, which is a CAGR of 19.1%. So it's expected to grow to $260 billion by 2025, which means at a CAGR of 21.5%. So import, say because of this, the import reduction has happened. So if you see from 2016 to 2019, we reduced our import from 57% to 49%, which means close to $15 billion of savings. And from 2019 to 25, it's further expected to go down to $29 billion, which will result in a saving of close to $66 billion. I think these are really very, very important figures for the future. So if you see, one important thing which is worth mentioning here, see, domestic value addition today is roughly still in the teens, around 17%. But the focus of the government and for us as an association to give inputs is to move it to the figure from 17% to 40% by 2025. What that means is the additional value creation because of this 40%, 17 to 40% will be $60 billion by 2025. So coming to this, I think we talked about this. I think the pain today, what we have is only 9% of the total production is high value, high value. It's mostly low value add, but high value add basically means more than 50% of domestic value addition. So which you see in this figure on the right hand side, even by 2025, we will see 237 billion of low value manufacturing happening in the country, and 23 billion will come from the high value addition. So we need to really focus on this part, how to make this portion bigger comparatively. And the electronic design, we are growing pretty strongly. I think it's covered in the next slide. So we grow from we'll grow from $13 billion in electronic design to $20 billion from 2016 to 2019, which is at a CAGR of 15.4%. I think many of the panelists already talked about. Today, there's hardly any semiconductor or ESDM company which does not leverage the Indian talent pool which is available. And there's hardly any semiconductor top 20 company which does not have a design center in the country, including the Taiwanese big names like MediaTek has a big design center both in Bangalore as well as in Delhi. So TI was the first one to basically set up its design center way back in 1985, much before India got into the liberalization mode. But I think it has been a great journey for TI. Since I am part of TI currently, so I can see there's hardly any chip which we design globally and which is manufactured globally, which is not being touched by the by Indian engineers in Bangalore. So Bangalore is definitely our second largest design center outside of US. And the same story is for many of our members, whether it is Qualcomm, Intel's of this world. I'm not sure. I'm pretty sure maybe even for MediaTek outside of Taiwan, India must be the biggest global design center. So this is a great source of foreign exchange, and Government of India is making right steps to ensure that this growth continues. And as I said, this is with some of the tweaks. I think there were some policy interventions both at the central government level as well as at the state government level at the Karnataka, where we may see probably this 20.1% being exceeded as well. So there have been some good success stories as well in terms of merger and acquisitions. See, Info Chips, which is based out of Gujarat in India, was taken over by Arrow Electronics, which is a global US company in semiconductor supply chain. Sunclub by HCL, SI2 and Wafer Space by Alton Calsoft Labs, Cerium by Tech Mahindra. So what is happening is, because of this lot of activity in the fabless area, and many of you must be knowing that we from IESA initiated SAFAL, which is a Semiconductor Fabless Accelerator Program, almost 3 years back, and it has been a great success. And for the country, for the Karnataka, so we have seen a lot of successes and many companies coming and joining this acceleration program, which was done together with Government of Karnataka and IESA together. So what is way forward for India? So I think what we are proposing, and we have been working, and the government, full credit to the government, we are working very closely to ensure that we incentivize and support design companies to grow in the country, and with focus on ease of doing business and some issues like transfer pricing. And we have been raising it with different issues to make it more transparent, make it more easy, so that this particular aspect does not become a stumbling block for the global design centers to set up their design center in the country. So apart from that, upscale capabilities of workforce, incentivize research, IP development, and product engineering. And Netra model is another initiative by IESA to ensure that when the engineers come out, they already have substantial experience in their second, third, and fourth year, so that they can easily be utilized without a lot of investment from our member companies and ESDM community at large, to put them on the job. So this is one of the initiatives, and we are planning to take it pan-India. And I'm sure Krishna during his talk will definitely talk about what initiatives we are planning as IESA to help basically upskill and our engineers. So some of the things which I would like to talk about, although I talked about with only 9% of the total products at high value addition. So products which have domestic value addition of more than 60%. In 2016, we did 4 billion. 2019, 7 billion. It's expected to go to 23 billion. So what it shows that we need to really focus on innovation-led design, design-led manufacturing. Design innovation and IP will help create high value add products, focus on new use cases, whether it is medical, agri, AV, EV, environment, AI, and ML. So what it means is that IESA has a big initiative of 1K, 10K, 100K, which means 1K startups, which will result in creation of 10K of IPs, and which will also result in the 100K crore of business value. So we also target on 100 fabless companies, 900 electronic product companies. We are also working with the government to have a seed fund of close to 7,000 crores and expand SAFL model, which I talked about, a semiconductor fabless accelerator model, which is in Bangalore, and expand it pan-India and have a kind of a pan-India focus on fabless accelerator, basically to leverage the talent pool what we have in the country, and a lot of people who are coming back from the Silicon Valley and are setting up their own startups in the semiconductor domain. Expand Electropreneur Park is another flagship of IESA, which was done many years back, almost 5 years back in Delhi, and that has created a lot of product designs in the country, and we are expanding it beyond Delhi, and now we have an operational Electropreneur Park, which we call it in short name as EP, in Orissa, in Bhubaneswar, and there are many others in the pipeline which we are working very closely with STPI and Ministry of Electronics and Information Technology to leverage the diversity of knowledge, diversity of needs of the country and expand this Electropreneur model. So, go to the next. Yeah, okay. So I think increased value addition in low value LVM products. Current value addition is 17%. Activities contributing assembly, test, PCBA and PCBA currently. Strategies: make recently announced PLI schemes based on value addition. These are some of the strategies which we are focusing on. Incentivize ATMP facilities, display fab and display modules manufacturing, LED manufacturing, power electronics fab, debt venture fund for working capital, interest relief of 3% on financing cost, impact of 60 billion additional value creation by moving from 17% to 40%, build up of component ecosystem and supply chain. So I think what on this forum, what I would like to basically emphasize on is that India and Taiwan really need to work together, while as Taiwan will continue to focus on the latest technologies. I saw in the slides before focusing on below 10 nanometer. So there's a good possibility, and we really request this on this forum, that some of those which are older technologies, whether it is 18 nanometer, 25 nanometer, or 45 nanometer, can be brought into the country, to India, and leverage the incentives what government of India is planning to give in the fab area. This will not only help Taiwanese companies to expand in the latest technologies back home, at the same time they will be able to leverage the Indian talent and the Indian market and start producing those old technology parts in the country. Thereby they can help the country like India to move slowly in the semiconductor space. I think I would like to stop here, and if you have any questions, please feel free to ask or ping me whenever you want. Thank you.
Thank you very much, Mr. Tushu. If anyone has any questions, please email them to us and we'll pass them on to our speakers. Next, please welcome Dr. Kai Anzhen, Senior Industry Analyst of MIC, a prominent think tank in Taiwan. make his presentation on the Taiwanese semiconductor business trends. Welcome, Dr. Chen.
Is my voice clear?
Yes, it's visible. Please make it full screen.
Okay. Okay. Yeah. Okay. Good afternoon, everyone. I'm Chen from MIC. It's a pleasure to have this opportunity to share our view with you about the semiconductor industry. My topic today is the trends and the business opportunities for Taiwan's semiconductor industry. Here's my outline. I will first talk about the market trends for global and Taiwan semiconductor industries, and then I will focus into the semiconductor demands driven by emerging applications. Then I will talk about the business opportunity for Taiwan's semiconductor industry related to these emerging applications. Finally, is my brief conclusion. Let's get into the first part, the market trends for semiconductor industry. The global semiconductor industry has a very strong growth since the second half in 2020. Here comes three reasons. One is the notebook demands driven by the pandemic. Second is the recovery of smartphone and the automotive industry that requires more semiconductors. The third reason is the U.S.-China trade war that caused order transfer effect. In addition to this, demands occurred in the second half of 2020. There's a background demand needs for from the 5G, AI, IoT, and the vehicle technologies. These demands will be a very steady increase of semiconductor usage. So we expect this demand will extend into year 2022 or even longer. So the forecast for global semiconductor market will continue to grow from the year 2020, 2021 to 2022. Now into the Taiwan semiconductor industry sectors. We divide industry sectors into IC design, memory, foundry, packaging, and testing. The growth in semiconductor industry also show growth in Taiwan's semiconductor industry sectors. Additional to the global growth, as 80% of the notebooks were assembled by Taiwanese companies. So the chips for notebooks are mainly produced by Taiwan's IC design house and foundries. So the growth in the second half of 2020 has even bigger in the Taiwan. And this momentum was carried over to year 2021. So we see as the imbalanced semiconductor supply and demand in the first half of this year. We can see that recently the smartphone and notebooks, the sales forecast for the smartphone and notebooks are seeing adjustment probably in the second half of this year. So the demands of driven by the previous three reasons probably will go down a little bit, but the background demand from 5G, AI, IoT, and vehicle technologies will continue to support the demands for semiconductors. Here we show you the foundry revenue distribution by technology nodes. The yellow and the orange bar at the bottom is the 5 nanometer and 7 nanometer revenue distribution. We can see that companies such as Apple, AMD, Qualcomm, and NVIDIA are all waiting in lines for the advanced technology processes. such as 7 nanometer, 5 nanometer, 5 nanometer plus. So there's a trend that more high performance computing chips are produced, and this need is continue to grow. In addition to the advanced technology processes, we can see that for processes for 28 nanometers or below now has a portion of 60% or more in the Taiwanese foundry. So in addition to high performance semiconductor chips, the chips with moderate computing power will also has a strong growth in the demand. So we just mentioned that there's an imbalanced semiconductor supply and demand. Let's take a closer look at all the factors. On the demand side, we can see the 3 reasons. The notebook demands increase caused by the pandemic, and also the recovery of smartphone and automotive industry that requires more semiconductors, and the order transfer effect caused by the US-China trade war. These demands will affect end user products such as notebooks, smartphones, and cars. So we list different chips related to these end user products on the right. Then let's look at the supply side. Due to this increased demand, the usage of the 8-inch and 12-inch wafers capacity reached 100% at the end of year 2020. And now the capacity utilization is still 100% on the first half of 2021. And also, we can see that foundries and IDM companies are also plan for increase their chip production capacity. However, we see that because the capacity increase needed 1.5 years or to 2 years from the fab construction to mass production. So this increase in capacity cannot satisfy the increase of demand right now at this moment. So we can see chips in different areas, but similar process node technology nodes are competing for production capacities. For example, in 8-inch wafer, display driving IC, DDI, power management IC, CMOS image sensor, and microcontroller units are competing for 8-inch wafer capacities. For 12-inch wafers, chips such as PMIC, TDDI, audio codec, memory controller, Wi-Fi, and RFICs are competing for technology, process technology in 12-inch wafers. In addition to this structural demand supply shortage, there's accidents in this year we can see that happens in fabs, such as the storms in Texas, fire in Renaissance, and earthquakes in Japan. These accidents also delays the manufacturing of ICs, cause the delivery time even longer. So we can see that different chips in different fabs are affected by this kind of accidents. So with this imbalanced semiconductor supply and demand, governments are rethinking the role of semiconductor supply chain to the development of national technology and the economy. So here we list shows you the distribution of semiconductor work specialization. After more than 30 years of work specialization, we can see that now foundries and IC packaging testing capacity is basically focused in Asia. And this kind of focus of capacity will face challenges of natural disasters such as earthquakes, typhoons, and also face threats from regional political tension. So governments worldwide are thinking about trying to develop regional resilient semiconductor supply chain. So here we can see that on the left bottom side, we list different countries have different policy incentives for semiconductor supply. So these incentives include R&D investment, tax benefits, and fab construction subsidies. So we can see some examples right now. For example, recently the announcement of U.S., Japan, and U.S., Korea cooperation in the semiconductor supply chain, and also in European Union recent announcement to have alliance of semiconductor supply. These are all examples for local or regional semiconductor supply chain establishment. So we can see that semiconductor supply chain is changing its deployment worldwide. In addition to the government's efforts, we can see chip makers are also making their own efforts to meet the global demand. For example, in IDM companies, NSP, NVIDIA, Intel, and Samsung all started their new fab construction or mass production in 2020 and 2021. In foundries, TSMC recently started its 12-inch fab in Arizona already. And then it also announced expansion of 12-inch fab in Nanjing, China to make 28 nanometer processes. In addition to TSMC, Powerchip, UMC, SMIC, Global Foundries, all these other foundries are also started their fab construction plan in the first half 2021. However, as we just mentioned, this production to mass production this new capacity, we need probably 1.5 to 2 years. So we can expect that the capacity, the newly added capacity, will not take effect until around year 2023. So we just talked about the global and Taiwan semiconductor trends. Let's get into the demand side. These new emerging technologies will have more needs for semiconductors. One emerging technology is the 5G. The 5th generation of mobile network now has been in operation in more than 60 countries worldwide. And also more infrastructure are constructed underway. So we see that 5G will boost semiconductor demand in several aspects. One is the cell phone adoption. Another is the infrastructure construction, and also the mobile edge computing deployment. So more semiconductor device will be used in 5G and 5G's applications. Another emerging technology is the combination of AI and IoT. Right now, we see that from the cloud, edge, and the terminal or endpoint architecture, there will be more application, more diverse applications in the end user side. So the devices for end users or the IoT devices will have more needs in different kind of operation or computing forms. So we see IoT chips will need more computing power and also different levels of data processing, analysis, and AI inference capabilities. So there's the diversified needs for IoT chips will also boost the demand for semiconductors. The third emerging technology comes from the automotive industry. There's a strong trend in the so-called case case in the automotive electronics. C is for connected, A is for autonomous, S is for sharing or services, E is for electrified. So from the internal combustion engine, the traditional car, to electrified car with connected function or autonomous functions, there will be more semiconductor used. So here on the right, we show the cost construction structure for a L3 electric vehicle. So we can see that, we can see that it takes about $3,000 per car for a general internal combustion engine car to have semiconductors to cover functions such as light control, rain brush, or display in the vehicle. So is this case trend, we can see that more semiconductor will be needed for a car, and we can see the increase in semiconductor cost is almost more than double. So this case trend will drive semiconductor usage in cars even more than ever. So for this emerging application, what are the business opportunities for Taiwan's companies? First, let's look at 5G. For 5G, Taiwanese companies' business opportunities come from the Open RAN. Here we show the architecture for Open RAN deployment. From the core network to backhaul to access, radio access, Taiwan's companies will have opportunities in white box servers, switches, and routers. So this is the strength for Taiwan's ICT companies. So we can expect that more opportunities for semiconductor sales along with this 5G Open RAN. The second opportunity comes from the IoT or AIoT. The Taiwanese government is promoting IoT vertical applications through this called Smart City Taiwan project. So we can see a different usage of IoT devices in smart factory, smart security, smart healthcare, smart education, and smart agriculture and smart transportation. All this will increase the use of semiconductors in different forms. The third opportunity comes from the electric vehicle. Foxconn recently announced its MIH-EV platform. In this platform, it will promote modular, flexible design for electric vehicles. And also, it will have the lightweight chassis design to share with its members, and also promote a stable electronics architectures, and also have a platform for autonomous driving functions. So with all these functions and the shared capabilities, we can expect that electric vehicle development in Taiwan will accelerate. So companies joining this platform has already reached about 1,800. So we can see more development in the future. So in conclusion, first, the shortage of semiconductor chip supply is caused by the increased notebook demands due to the stay-at-home economy driven by the pandemic. Also, it's caused by the recovered smartphone and automotive electronics demand. And the third reason for the shortage is caused by the order transfer effect caused by the US-China trade war. So with this imbalanced semiconductor supply and demand, now semiconductor is more of strategic importance for every country. So governments worldwide are making policy incentives to stimulate the development or establishment of chip production capability, and also try to establish resilient semiconductor supply chain through national cooperation. And in addition to this surge demands caused by pandemic and also US-China trade war, the 5G, AIoT, and the vehicle technology will have a stable demand increase for semiconductors. So with Taiwan has already have companies and also platforms formed for these emerging applications. So we expect that companies in Taiwan and the companies cooperate with Taiwan's industries will have opportunities to join this development in the future. So this wraps up my presentation today. Thank you.
Thank you very much, Dr. Chen, for your presentation. This concludes our presentations. Now we're going to proceed to the panel discussion session. The topic, Silicon Handshake, how Taiwan and India can fast forward its synergies. Before we start the discussion, because of a few more panelists have come online, let's take a minute to take one more group photo with all our speakers and panelists. So with every panelist and speaker online right now, please turn on your video. And like before, we'll count down to 3 to take the photo. But first, let's take a second to end the sharing. Okay, sorry for the interruption. So again, would everyone look at their camera and smile on the count of 3? Let's just make sure that everyone's camera is on. Okay, so I think that is everyone. So on the count of 1, let's look at the camera and smile. And 3, 2, 1. Hold for a second. Thank you. And for the second photo, let's put our thumbs up. And on the count of 1, 3, 2, 1. Thumbs up. Hold it for a second. Thank you very much. We got it. Now, without further ado, allow me to introduce the President of the Foundation for Commerce and Culture Interchange, Dr. Dennis Hu, as today's moderator. Let's welcome Dr. Dennis Hu.
Thank you. Good afternoon, everybody. So we just finished our photo session and the thumbs up session. Now we are entering our panel session. Thanks to all the speakers' previous session, and we have learned a lot of the information and the fruitful knowledge. As our chief guest from India, the keynote speaker, Dr. V.K. Saraswat, you mentioned that a lot of the information about the Indian market, it's a 2.3 times increase by 2025. It's about $160 billion US. I think it's warming up our panel discussion later and enlightening some of our hope in the future about the Taiwan-India cooperation in the semiconductor industry. As I mentioned that now we are entering panel discussion. Join me today and join our panel today, we have the India government policy maker, industry leader from India, and major Taiwanese companies which invest in India for a long time, as well as the expert from the Taiwan Semiconductor Research Institute, leading one. So, ladies and gentlemen, may I invite you to welcome all the panelists today. The very first, I would like to introduce Mr. Saurabh Gaur, the Joint Secretary of METI, the Ministry of Electronics and IT. Yeah, Mr. Guo. Oh, yeah, just had share. Yeah. I think very nice to meet you again. I think last year we have met. So also in a forum. Welcome. Mr. Saraswat has been a key person behind many recent policies which are attractive to the IT and electronics industry. And many Taiwanese companies consider India as their destination of operation. I think it's a huge contribution by him. As Joint Secretary at METI, 3 goals handle policies, programs, and schemes of government of India pertaining to electronics and hardware manufacturing. Welcome, Mr. Guo. And we have another second speaker from India, is Mr. K. Krishnamurthy, the President and the CEO of ISA. Yeah, welcome, Mr. Murthy. Mr. Murthy is an electronics expert with over 4 decades of global experiences in hardware system design, ASIC, and the system on chips, and the wireless telecommunications in Asia Pacific, USA, and Europe. He also held the position of the honorary vice chairman and chairman of ISA. This is a professional body of about 500 plus, I think, Indian electronics and semiconductor companies which connected well with India government. Welcome, Mr. Murthy. And I would like to introduce Ms. Ritukana Mandel, the General Manager of MediaTek India. Ms. Mandel, can you? I cannot see you. Okay. Oh, yeah, okay. Okay, welcome, Mr. Mandel. Ms. Mandel. She is the General Manager of MediaTek Bangalore. In addition, she's also the Director of the Advanced Technology Team, where she is responsible for foundation IP and advanced CPU design across MediaTek products. Welcome, Ms. Mandel. And we have the Dr. Wen-Kuan Yeh. I think you have already listened to the Dr. Yeh's speech. So Dr. Yeh is a PhD in electronics engineering from National Jiao Tong University, Taiwan in 1996. And with over 25 years experiences in Taiwan semiconductor industry, Dr. Yeh almost joined all the big company in semiconductor industry in Taiwan, such as the TSMC and the UMC. Now, he is currently the Director General of the Taiwan Semiconductor Research Institute, TSRI, which is the over 30 years organization, and it's a major semiconductor think tank and a research institute in Taiwan, which is a lot of the contribution for the Taiwan semiconductor industry growth. So welcome, Dr. Yeh. And last but not least, we have the Mr. Frankwell Lin, the co-founder, chairman, and the CEO of Andis Technology. Yeah, Mr. Lin. Oh, yeah, I see you. Yeah. Mr. Lin, the chairman of the Andis Technology. Andis has been recognized as one of the leading suppliers of embedded CPU IP in semiconductor industry. Andis also won a reputation of leading technology company with awards such like 2012 EE Times Worldwide, Silicon 60 Hot Start to Watch, and 2015, the Deloitte Technology Fast 500 Asia Pacific Award. I think Frank will receive a lot of the award as well. So I think it's a great achievement from Frank Well and Andis. And also Frank Well is also the board director of RISC-V International since 2020. Welcome, Mr. Lin.
Thank you.
Yeah. So without further ado, as we have seen, I hear a lot of the information and very informative speech and a fruitful speech presentation in previous session. So we know in the future it's a good opportunity and some space for the Taiwan-India cooperation, not only in like IT or electronics only, but also in the semiconductor area. So, but I think the first question I would like to raise it to address to Mr. Saurabh Gore. I think it's very important about government if we want to do some investment in some country. Therefore, I think it's very important to talk about particularly in Métis. Métis has actively been engaged with the tech industry to come up with policies facilitating attracting foreign investment. The recent being PLI scheme and also the expression of internet announcement for semiconductor fab. Can you please elaborate on the schemes and how those schemes are beneficial for Taiwanese companies who look to engage more with the Indian market? Thank you, Mr. Go.
Thank you, Dr. Hu, esteemed panelists. It is indeed a matter of great pleasure for me to be speaking at this forum again. I very much like the heading of the title of the discussion, Silicon Handshake, and I'm sure we'll move on to Silicon Embrace next time as we get more integrated, India and Taiwan together, and India becomes expanded footprint in electronic manufacturing over a period of time. So we have had some very strong policies around electronic manufacturing for quite some time now. And the most recent one is the production-linked incentive scheme. As part of the production-linked incentive scheme, companies which are champion companies, which are already having a huge manufacturing footprint, or they enjoy a large share of global manufacturing, they are encouraged to either come to the country or expand their manufacturing in the country, and with the promise that they will be given incentives which are linked to production value. So suppose a company is doing say $1 billion worth of manufacturing, 6% of that, which is 60 million of the production value, will be given back as cash back to the company. And such kind of scheme, it will be there for 5 years. So for the 5 years that of manufacturing, incentive will be available ranging from 6% to 4% on the output value. This scheme has been made available for the products, that is, say, mobile phones and IT hardware, that is servers, laptops, tablets, but also for electronic components and semiconductors. So we've already seen Taiwanese EMS companies, the likes of Foxconn, Wistron, Pegatron, becoming a part of the scheme for the mobile phones as well as for IT hardware, but also the component manufacturing companies, whether it is the PSA group and its associate companies, and even companies like Foxlinks and others, which we've been calling and which are expanding, which are also again a part of the PLI scheme. We are very much welcoming investments in semiconductor space also. Our electronics market today is around $80 billion US. It has grown despite COVID also. We have been growing almost for last 5 years at 23% cumulative average growth rate. So it is a huge year-on-year growth that we have been experiencing. And once we are, in fact, Taiwanese companies were among the first ones to show how to adapt to the new normal in COVID era by arranging their manufacturing facilities, ensuring social distance and all of them are back to their full manufacturing now. So even during the second wave also, the Taiwanese companies were able to by and large do manufacturing at huge scale. In the post-COVID world, or even during the COVID world also, we are looking at growing below, much above the present rate of growth and reaching between 30 to 40%. And companies under PLI have promised production worth almost 130 billion US dollars in next 5 years. And we are going to have huge subsequent rounds of PLI also. We very much welcome companies, whether it is a UMC or a TSMC, which is usually aspirational, but even compound semiconductor space also. Companies like Wen-Kuan, these kind of companies also to come and manufacture in the country. Similarly, the companies which are in the semiconductor packaging space also, for them, the PLI is available. So we are looking at becoming, our mobile manufacturing is expected to go from present $33 billion to almost $150 billion in next 6 years. Similarly, IT hardware is going to grow from $2 billion to 40 billion US dollars, because we again have the likes of product companies also such as HP, Dell, Acer, Asus. These also have committed huge production in the country, not just for Indian market, but making in India for the entire world. So we are hopeful that with this kind of product ecosystem, I'm sure that the design ecosystem and the fab ecosystem is also going to come to country, and we very much welcome those investments.
Yeah, thank you. So I think it will be a very good information to share with Taiwan's company, because right now we got a lot of the audience online. You know? So I think it's very nice to know that. So you just mentioned we already have some big company like Pegatron, Foxconn, Wistron, as well as other big companies take advantage of the PLI, this scheme, to invest in India. And also focusing on the domestic market in India. I think it's the topic is how to adapt the manufacturing locally. And I think Indian government offers some scheme as well as some policy to help them to settle down well. Even now in the COVID-19 pandemic time, I think it's so just mentioned it's over half, over 60-70% of the production activity already recovered. I think it's very nice, especially during this difficult time. I think without your support, I think it cannot be achieved. Thank you. I think it's a good sharing for the Taiwan company about those information. So if we talk about the Indian government, what their effort to do that, I think we can share of some of the information, or maybe we should ask some experts to talk about the need or maybe some of the challenge from a Taiwan company. I think Dr. Yeh, Dr. Wen-Kuan Yeh is the expert in Taiwan semiconductor research or industry about those a lot of the topics. So to talk about the insight or information, so I would like to address this topic to Dr. Yeh. What do you see as some of the biggest challenges to Taiwanese companies setting up the fabrication plants in India? And what's your advice for this, for some solution or any challenge you have seen? Dr. Yeh, can you give us some of your comments? Dr. Yeh, Wen-Kuan.
Okay, I just from my opinion, personal.
Yeah.
You know, I just give some experience. I'm the first intern in TSMC in 1989 when I am the student in the master degree first year. Before I joined the TSMC, I don't know anything. What is a semiconductor? And then how don't know all the information? Because it's very tough. I cannot gather this information in my school. I must be understanding and learning in the TSMC first. Took a long time. I finally finished my master's degree, and I know what the future. So I inspired me to pursue a PhD degree. So that's my experience. So in the past 30 years, long time, the Taiwan always have, like me, have enough the young guy but like to join this semiconductor industry because we can looking forward the future is successful. So very important for young guys, not only for TSMC, for MediaTek and some design house also. Circuit design and the fabrication is parallel, but it's close together because the design must be delivered by the advanced process. The Taiwan have a very good ecosystem, enough young guys supporting. So if India want to fabricate this, copy this ecosystem, you can take a huge money and take a long time. So I think you cannot just copy Taiwan. Maybe unique, focus on some specific topic. I just some experts, so I say, gain nitride for high power, maybe for smart card, or silicon carbide, germanium, and new high frequency for the satellite, high frequency communication. For unique, the industry maybe can try to set up some platform and encourage some new business can make successful in that. For logic, it's the very long and very huge mass production. Like the TSMC always every month is 2 million chip the wafer, maybe made. So it's a very big business. You cannot compete it because it takes a long time. The very well the management for the fab, they're very unique, they're very high here. So this is including the management, manpower management, including the maintain the equipment, very stable. So it is not only for technology, it is a management. So India, you want to do that, I see it maybe take a long time, must be transfer all the system can be complete. So I suggest for unique the industry, for unique the application, like a high power car, electric, or some for communication. Have some unique platform like a satellite platform, can like a spotlight, like a SpaceX, have some new communication system can make it in India, or some unique industry can be successful in India. You use this business ecosystem to access some fabrication can build up in India. That's my suggestion.
Okay, thank you, Dr. Yeh. I think Dr. Yeh got early experiences about entering the semiconductor industry ever since he was in university, I think. So that's why I think during his speech, previous speech, he talked about like some program when his organization to cooperate with the university. Ever since the student in the university, they got a kind of like coach training about a semiconductor young talent in the future. So, which will begin in school. I think it's based on his early experience. And that's why we got so many experts, so many resources, human resources in Taiwan about semiconductor technology. I think this is what one of his comment. And the other is like talk about the ecosystem. Ecosystem, of course, is a lot, but especially mention that not only in hardware equipment or not only the hardware facility, but also some of the soft, you can say soft power, okay, soft strengths like manpower management, skill training, and some management in the equipment. So it's more about those like concept awareness of that. And the third one, he just mentioned that maybe we can, Taiwanese company, or maybe we can join India together to identify some unique or focusing industry or direction, such as like electric vehicle, okay, somebody says electric automobile, those the facility, those products direction, or satellite, as he just mentioned in his previous speech about like a CMOS image sensor, if I'm right. Okay, Dr. Yeh, okay, I still keep a good memory about your speech about a CMOS image sensor, which is used in space tech and the satellite, especially in because India is good in like surveying technology, but Taiwan is good in supply those like CMOS image sensor in the semiconductor industry. Like that one is another opportunity we can cooperate in the future like that. And also some of the communication, those direction. I guess it's what his comments on that or his advice, I think we can all take into account to think about it. But talk about the ecosystem. So Dr. Yeh just mentioned about what he see and his comments. So I would like to address this similar question to IESA, Mr. Murthy. Okay, so what is the overall ecosystem currently positive for a semiconductor company to look at in India, and what are the areas of improvement? And we talk about IESA. IESA is a major electronics and semiconductor organization in India. So what's the IESA extending support to foreign tech companies in India entry? Can you share with us? Mr. Murthy? I cannot hear you.
Thank you,
Okay.
Thank you very much.
Yeah, okay.
Please. For giving me this opportunity to be part of this Indo-Taiwan Cooperative Friendship Forum, and have been very educative so far from the presentations that was going through since morning. The very opening remark, the Director General of Foreign Trade said 70% increase in bilateral trade despite the COVID pandemic. That itself was a big eye-opener. That shows how we have managed, despite the two countries have managed, despite the challenges of the pandemic. And the ICT manufacturing in India, manufacturing and supply to India from Taiwan, apart from the EMS, is following pretty much into semiconductors, also in small ways. But I would like to give one parallel of what happened maybe about 2 decades ago in the automotive sector, when major Japanese and Korean manufacturers like the Toyotas and the Hondas and the Hyundais set up their manufacturing unit in India. And they were at that time coming in with very low-end, small, and very small or entry medium level kind of cars for the Indian market. And I think today, after 20 years, all of them are exporting their cars to global locations made out of India. So that's one success story that I keep talking about every time I talk about semiconductor and the semiconductors roadmap, how we have already made it happen in a complex system like in automotive. It is definitely possible in any other segment. But having said that, to answer to your question, Dr. Ho, India's strength today, when in respect to semiconductors, is in design. And Ms. Rituparna is there from MediaTek. She will vouch for what I'm saying. India probably is today the second biggest semiconductor design powerhouse in the world after the US and after the Bay Area. We have practically every design, every semiconductor company having a major design presence in the country. And I think our and this is just maybe 15 years old, not even 15 years old, less than that. Maybe 2007, 2008 is when this started growing, and in about 12, 13 years, our design value is of the order of about 25 to 30 billion, very comparable to what was presented as the design value of Taiwan. So this is definitely one strength that we have, and products for the world are getting designed out of India. Now, it was the conventional ASICs and system on chip where I started designing 2.5 decades back. But today they are foraying very comfortably and confidently to the new technology application domains like AI, ML, IoT, 5G, etc. So that transformation of the design community to adapt from one technology to another, starting from 180 nanometer, where I did my first design, to the last design I did 3 years back was in 7 nanometer, 2 years back is in 7 nanometer. I think the engineers are able to comfortably adapt across application segments, across process technology segments in terms of design ability, using an existing technology node, using the PDKs, designing products for the world, not only for India, but for the world. I think that's a major step India has achieved. Now, look at the other part of the pillar, and there were 3 components that was presented earlier. The second part is the software, particularly the embedded software which makes the product. India is an acknowledged world powerhouse when it comes to software in general, embedded software in particular. So that is the other strength that India has today. So what is the synergy? It's very obvious that we can, like what Joint Secretary said, we are ready to embrace, not handshake, both in design and in software. Now, let us look at the third component, which is the manufacturing. Okay, so this is where IESA is working very, very closely with the Ministry of Electronics and IT, with Mr. Gaur's department, almost on a daily basis, I can say. The number of meetings we hold every week is almost 1 per day. That's the level of interactions we have, and the government is very, very supportive of the suggestions and inputs that we give. So when it comes to manufacturing, I think we don't have to look anywhere else. I think India should look at Taiwan. Taiwan should look at India for a solid handshake, because Taiwan is an acknowledged powerhouse when it comes to manufacturing, both at the systems level as well as at the semiconductor level. Now, the question is, semiconductor being ubiquitous, and I don't want to go into the numbers because all the numbers have been spoken about, 40 billion strategic, 400 billion total. So I don't want to repeat those numbers again. But if a particular segment of a business is contributing close to 7-8% of the GDP, it has got significant potential. Today it is around 3.5%, but in about 5-6 years it is going to touch anywhere from 7 to 8% of the GDP, and that's a huge impact value. So that's where IESA recognizes the value of this segment of semiconductors and electronic systems, and we are working with the government to put the policies in place. But I think the TSRI Director General, Mr. Wen-Kuan Yeh, I hope I got the name correctly, was very correct in saying that at the end of the day, technology management means human resource management. Yeah. Without laying the foundation, without laying the building bricks for managing technology, which is human resources, it's not going to be possible in any stretch of imagination to become successful. So IESA's next thrust area is skill development. We are putting in place a comprehensive skill development plan, again, working with multiple organizations who have, at the end of the day, companies like MediaTek, companies like Intel, all of them have today talked to IESA. Hey, Krishna, we have a serious problem. What is it? We are not able to get enough engineers to do the projects. Particularly after the pandemic, when companies are coming out, launching new programs and projects, there is acute shortage of talented people. So this is not a problem that is going to go away by itself until we put processes and practices, very strong processes and practices, not necessarily only at the engineering schools, but maybe a little earlier. So we are coming up with a comprehensive proposal, and we'll work with the government, roll it out across the country before the end of this year. And that's going to be the pillar, the major pillar on which we will grow our semiconductor industry. Now, only one other aspect I would like to talk about. Dr. Saraswat talked about R&D fab is in the works. I think that's absolutely the right thing to do, to once you have the talent development activities identified and addressed, proper processes put in place, the next one is to have an R&D fab. And I think that's an absolutely right step to go to. And newer technologies like gallium nitride, silicon germanium, FDSOI are also in consideration at different scales. Some of them like SENSE in IISc, IIT Bombay, they have a SENSE lab, which is not a commercial lab, but they have a very good R&D capability there. Similarly, there is a CMOS fab in FCL Chandigarh, which is currently used for strategic requirements. Bharat Electronics has a slightly older generation discrete components fab. And then, of course, DRDO also has its own, but all of them are R&D fabs or R&D centers where some amount of rudimentary development happens. But combining all this into a full-fledged R&D fab will probably be the first important step. And this is where I would expect companies and other fabs from Taiwan to come and join hands. And I think that will make a big difference. Because once the human resource requirements are addressed and we have an R&D fab, it will be mutually beneficial to both countries to grow on this. And particularly, I would like to mention here the geopolitical situation, which you are right in the middle of that. I think it mandates, I don't think we have an option, but I think it mandates for us to de-risk and also distribute capabilities geographically dispersed. And I think India will be a willing partner to work with you. And specifically to the fab, I think trying to do a 5 nanometer, 7 nanometer, or any of the FinFET nodes is probably not the right thing for India to go after at the moment. And I think discussions are happening with the ministry. There are divergent views, but that's perfectly okay. In a democracy, we would like to have as many views as possible. But in order of priority, maybe IESA will work with multiple entities to see whether we can get a good analog fab. I think Dr. Yeh was also suggesting to that, identify a few application segments, identify some critical components as part of that, in which, in my opinion, particularly coming from National Semiconductor, Texas Instruments, and Rambus IP development kind of companies, I understand the value of critical IPs and special function devices, which a very good analog fab, which does not require any of the FinFET nodes. It will be very comfortable with 65 or 40 or 45 or even 28. It's more than enough. That and a scalable CMOS fab, which probably starts at 40 and scales down to 20, 28 or 22, are the two fabs. If we can put it into operation in the next 2-3 years' time, probably India can create 80, India can meet 80% of its component demand out of this. Again, not in 2 years' time, but maybe it will take 5 years, may take 7 years. But the last 20% is where you need all the FinFET technologies or the foil technologies and stacked dies, special 3D packaging technologies and things like that. I think that's something which sensibly we can delay it. We will allow it to naturally grow into that, like exactly what TSMC did. What started as an ITRI lab today has become a global giant. It allowed to grow over a period of time, organically and naturally as the demand picked up. So in India probably will be looking into this. The other area where Taiwan and India can immediately do a handshake and an embrace is the ATMP, assembly, test, marking, and packaging. This again is something where we don't even have to wait for the fabs to happen. The wafers can come. We as a country, as a government level, we have to set systems and processes in place where within 36 hours of the wafer arriving at an Indian port, it should be out in a global warehouse. That kind of turnaround time, if we can assure, and at a lower price point, and ATMP will be very advantageous and very attractive to companies in Taiwan. I think this is another area of cooperation that I see we can work together immediately. I will stop here, and if there is another round of discussion possible in the time available, I will talk. But otherwise, we can always talk in later. Thank you.
Okay, thank you, Mr. Mosley. Thank you for your very practical and tangible sharing. I guess we have learned a lot about practical and tangible information. You got you just mentioned that you got a R&D fab in IIT Mumbai and Chandigarh like that. I think maybe it's a good information to share with the Taiwanese ICT industry about what are the further details information? Maybe we can discuss this one later on after this forum. Okay. So I think I would like to get some more information.
I visited
about
ITRI in 2017, and I was fascinated by the growth or how ITRI has transformed an industry in Taiwan. So I always talk about the ITRI model whenever I get an opportunity. Thank you.
Yeah, very tangible, very practical. And also, we have learned that like in ISA, we are launching some of like a skill development. I think just like Dr. Yeh mentioned that it's a foundation. Actually, it's a foundation for semiconductor industry growing. And we are happy to know that also in India, you got like a second design power in the world, I think, right? You just mentioned that. I think in Taiwan, we also got a lot of the design house. Perhaps this is another area we can dig in for the further cooperation in the future. I think we can explore that later on as well. And then you mentioned you are like a new product, like in AI, 5G, IoT, those the direction. It's also is some kind of like a direction in Taiwan, like Dr. Yeh mentioned that previously. Also in speech in Mr. Kusu, his presentation, I just learned that you have mentioned about in ISA, you got an innovation-led design and the design-led manufacturing. So I think it's also some kind of like your scheme in this kind of the technology management philosophy. I think also in this area, we can also share in the future between Taiwan and India to share with the industry. Okay, thank you, Mr. Murphy, for your sharing. I think we got a sharing from the industry leaders. And so we talk about Taiwan-India cooperation. The further practical thing is the real player. So my next question I would like to address to Ms. Ritupana Mandel about as a MediaTek invest in India for a long time, and the MediaTek India's establishment and the continued growth serves as a great example of Taiwanese fabulous semiconductors, successful collaboration, and the integration into the Indian market. I'm wondering what were the strengths that MediaTek saw in India when it decided to set up facilities in India, and have these strengths changed over these years? Could you share with us about your opinion, Ms. Mandel? Thank you.
So first of all, good afternoon, everyone, and thank you, Dr. Hu, for giving me this opportunity to participate in this panel discussion. And good afternoon to all my fellow panelists as well. So as you all probably are aware, MediaTek actually entered India market almost 15, 16 years ago now. It started up by setting up operations in Noida, through some organic acquisitions, so to say. I think so. One of the things is that India is extremely strong when it comes to technology talent, right, and innovation. And like many of my fellow panelists have mentioned, and Rajiv also mentioned earlier, technical expertise in the country is at par to global standards, right? And this has been the case for years and decades right now. Started off, I think TI was one of the early players who recognized this talent and kind of set up shop in India, right? And then there were many other global players who followed, you name it, whether it's a Qualcomm's, Intel's, AMD, ADI, you name it, we have a presence of some of the biggest global players in India. Now, given that India is strong on talent, we also have a huge number of, qualified youth eager to enter in this industry. So, there are a lot of, college pass outs who are kind of interested in this whole electronics, semiconductors, computer science kind of industry, right? and not only towards towards their own personal growth, but also subsequently leading to the economic development of the country, right? So, that is the way I believe the youth is kind of looking at their own growth, kind of paying into the economic growth of the overall country. So I think, like other companies, MediaTek saw this, great talent pool that is available, and the strong ecosystem around it as well, right? Whether you call it the EDA partners, you have the other contracting companies, the whole ecosystem around it that allows you to kind of run a very large and a very successful R&D team out of the country, which works on both aspects of hardware as well as software design, right? So it is not limited to only one area. And it is really the strong Indian R&D talent pool that has enabled us to remain relevant in India over the past years. And, I think Rajiv mentioned that in TI, and I also come from TI, right? That is where I spent my initial part of a big part of my initial years in my career, that any chip that is done, across as TI's market is touched by the India Center, I can confidently, stand up and say the same is true even for MediaTek, even within this last 6 years, from the Bangalore R&D Center, and also from the Noida Center from a software aspect. So if you look at it, whether it is wireless chips, whether it is smart home, whether it is IoT applications, infotainment for automotive, you name a chipset, right? And it has been touched by some team in India, and some of the very critical parts. So whether it is the processor design, whether it is the overall SoC design, whether it is the modem software, a very critical part of those things are done in the R&D centers here. And it is because of this strong talent pool that we have kind of grown over the years. Now, in terms of what has changed, so this was this is from a talent building and R&D center. Now, apart from that, if you look at it, India is also a very important business and consumer opportunity for MediaTek, right? It is a huge marketplace for MediaTek as a company in terms of business. One of the strengths, if you look at it, the Indian consumers kind of know exactly what they want. They have very unique requirements and unique needs. And the secret of the success in terms of MediaTek is the very good partnerships that they have built up with Indian OEMs and with Indian customers to identify what those unique needs are, and kind of build that into the products that have been successful in the market. So one of the things that we know about is the G90T chipset that was used in the gaming phone, right? And that is very kind of driven towards Indian market needs and the kind of gaming opportunities that a big mass in India is kind of looking at. So understanding the unique requirements and of the discerning Indian consumer has been a big learning, and has enabled this learning has actually enabled success of MediaTek as a business as well in India. So I think that continuously changes as well throughout the years. In addition to the talent pool that is available from an R&D partnership, is also the kind of business partnership that we have with India. So that is what I would like to share.
Okay, thank you, Ms. Mandel. I guess there's a very important message she delivered is for the Indian unique market, unique requirement, unique needs for the consumer in the Indian market. So the Taiwanese company, if you want to enter in Indian market, okay, so you have to know their unique demand. So that's one of the advantages which the MediaTek for the Indian market. Like she just mentioned, like cooperate with successfully with the Indian OEM partner and successfully in Indian market-driven design, like you mentioned, like a gaming or maybe special mobile chipset like that one. I think it's very important. But without Indian partnership, so it also unique demand from the consumer couldn't be discovered. That's one of the what you mean that why MediaTek so successful in India. And also Ms. Mandel also mentioned that I think this reflect Mr. Murthy and Dr. Yeh mentioned that the young talent. Okay, so the technology, young talent, and the innovation, very creative ideas from the Indian young talent, and the qualified youth engaged and eager to enter in this promising industry. So it's a kind of the motivation from a young talent. So that's why a lot of the motivation from young talent. So it's an ecosystem. You gotta lose the potential young fellow enter this industry. So what they need is like Mr. Murthy mentioned that some skill development in your ecosystem to combine to fully develop your potential power about the young talent. I think it's a good linkage about our panelists. You know, your comments is consistent together. I think it's a great discussion. Thank you, Ms. Mandel. So we talk about the MediaTek development in India. Also, next question I would like to address to Andy's chairman, Ms. Frankwell Lin. So, as per your extensive experience globally in developing a semiconductor market at various regions, now we talk about India, but you got a lot of the experience globally, okay? So we are developing the semiconductor market in India. How do you see the current supply chain disruptions that are prompting Taiwanese fabs to look at spreading its manufacturing more closely to key markets such as India? Additionally, what will be your advice to both India and Taiwan in working together for their respective aims? I think from your a lot of extensive experience globally, I think you can share with us about your advice, your comment. Please, Ms. Lin. Mr. Lin? I cannot hear you. Did you turn on your unmute?
Mr. Franklin, please unmute your microphone so we can hear you. Thank you.
Okay, can you hear me?
Yes, now we can hear you. Please go on. Yeah.
All right. Okay, thank you, Mr. Hu, to invite me joining this panelist. With these experts' opinion, I appreciate what I learned. Now I would like to say between India and Taiwan, I see some complement role in the world. So let me share this slide with you. I'd like to focus on semiconductor sector, especially we know in India the best resources you have is the talents. Like Krishna said, the IC design software and a lot of technology design talents. That is the best gift that you have. And we learned that you try to build your IC design ecosystem. Today, when I say IC design ecosystem, I would like to first exclude those foreign design centers. We know, for example, Apple, Broadcom, Amazon, Facebook, Cisco, they all have their design center in India and they have design center in Taiwan. So today we don't talk about them because those design centers, when they have work, they report and they design. And they make decision based the instruction from perhaps other country. But I would like to focus that the complement part between India and Taiwan. So for IC design ecosystem, India tries to build. We know some of them perhaps will make their own decision to do the chip or SoC that will mainly designed for India domestic application, which is important because we know India has so many population. You have a very high GDR, GDA. Then the domestic market is so huge. So I believe domestic IC design houses has their own chance if they make their own decision. And certainly depends on different kind of business model. They may also choose to provide their service to other, like upstream or downstream companies. So here we are. I added this slide to say that the two complement parts I can see in between Taiwan and India is first the combination of India's IC design ecosystem and Taiwan's foundry and IP ecosystem. When I say foundry ecosystem, that certainly include the famous TSMC, UMC, and power chip, and also the packaging and testing industries. And then in Taiwan, it is very clearly defined who is IP companies. So we have several IP companies like eMemory, Andis, and M31. They have their expertise and their focus. So the IC design ecosystem in India could co-work with these foundry and testing, packaging, and IP ecosystem in Taiwan to make their own chip. However, the second set of the complement parts I observed is that the same IC design ecosystem in India could provide their service, could provide their talent, pools, resources to the IC design houses in Taiwan. Well, MediaTek is a very successful example we can see, and yet there we have top 20 or so big IC design houses like Realtek, Sunplus, Novatech, Phison. They could also perhaps have their subsidiary or their subcontracting or their design center requirement in India, which I believe the IC design ecosystem you try to build will provide help. So we all know that there's a speak like IC is kind of a rise to the industry. So building IC is the way to help building industry. But no one can do everything. So together with India and Taiwan's overall ecosystem, I think there is a very good opportunity to the IC design ecosystem, no matter it's focused or targeted to build the chips for India, or it is targeted to build the chip for the world. And that's my opinion for Dr. Hu's question. Thank you.
Thank you, Mr. Lin. I think you just point out it's also very tangible direction for Taiwan-India cooperation. Actually, you just shared that what is a complement to each other. I think it's very accurate and a very tangible direction. IC design to the ecosystem, foundry plus IP ecosystem. I think it's also echoing our other panelists mentioned that, like Mr. Mosley and Ms. Mandel and Dr. Yeh, their comments. I think this definitely is one of our direction to dig in, to explore in the future for the cooperation. So design, semiconductor design. Okay, so everybody talk about the design now today. All right, I think, well, I think we are almost running out of the time. Although, actually, I just received a lot of the questions from the online audience. They want me to ask. I don't think we can ask all of them. So I think I would like to, talk about, we got a lot of like industry leader, we got like a company, senior management, and also some researcher think tank from the government. So I think to all of them, from my point of view, the company, if they want to invest in another country, they are not only talk about the industry cooperation, but what they will concern is that in the local, in that nation or that country, the government, what's their philosophy, or maybe what's their resources. So I think I would like to address this question to Mr. Saurabh Gore again, okay, the Joint Secretary of METI. So a lot of the Taiwanese companies, if they want to invest in India, so could you tell us for those high technology investment, they need a high level hand holding and a policy support, not just for investment, So, but also not only just for investment, but also for business operations for initial times. So how is India's ease of doing business and other proactive support systems delivering a comfortable business environment for the investors, especially to Taiwanese company? Could you share with us, Mr.
Thank you.
Scott?
Thank you for asking this. So while we look at making India the global electronic manufacturing hub, we consider companies not just as investors, but as partners in this entire ecosystem. And that is where we are very keen to have companies from all geographies, and especially Taiwan, to come and become a part of the Make in India story and manufacture for the entire world. While my fellow colleagues on the panel have spoken about the emphasis that is being laid on design-led manufacturing, having more design houses, and the fact that India enjoys tremendous talent pool also for doing the designs for the entire world, but for manufacturing also, and setting up for a company which is coming to India and interested in finding land, ensuring that they have ready-built factory sheds available. We have electronic manufacturing clusters. There are 20 such clusters across the country, where almost ranging from 200 to 500 acres of land and different clusters is available. Already 3 different clusters from Taiwan have taken great shape. There's one cluster in the greater Noida area, which is in the northern part of the country, in the state of Uttar Pradesh. There is one in Karnataka, in Bangalore, which is our Silicon Valley, which is where we have in Devanhalli and Hosur, we have the likes of Wistron, and Delta, and so on and so forth. Similarly, there is one cluster which has come up in the southern part of Tamil Nadu, in Sriperumbudur, where we have, and Tirupati. In fact, these two areas which are 50 kilometers from each other, in states of Andhra Pradesh and Tamil Nadu, where we have Pegatron, we have Foxconn, we have all their associated companies also. The PSA group is also there. So all these companies have been able to find great hand-holding support, not just from Government of India, but from state governments also, which are now competing with each other. Today, if a company from Taiwan lands in Delhi or in Chennai, there are people who are going to receive them, and for each company, we are going to have specific hand-holding support. There are, for example, special institutions. There is Invest India in Government of India, which has a Taiwan desk, which is a nodal agency for promoting investments in the country. Then we have Guidance Tamil Nadu as a separate agency in Tamil Nadu. There is a Invest AP, Economic Development Board AP, Invest Karnataka. So there are these agencies which are everywhere. We are offering very competitive land rates. For example, today our land either on purchase or on lease, long-term lease for 33 years, 50 years is available at very competitive rates. Our power rates also are quite competitive. In dollar terms, it is actually around 8 to 10 cents per unit, so which is hugely competitive, and the quality of power is also great. Similarly, we have taken measures around ease of doing business in terms of the single one nation, one tax. So wherever you are putting your company across India, there is a one goods and services tax, which is uniform. So 35 different taxes across states were put together to bring a uniform GST. Similarly, every company actually can become a SEZ. You can take the facility of a custom bonded warehouse so that every company which applies for that and gets it, they can enjoy duty-free import of capital goods, duty-free import of raw materials, as long as they are for export purposes. Similarly, there are enablements around if you are importing second and refurbished plant and material also. If they have a residual life of 5 years, they are allowed to be imported. So, and then in terms of resolving insolvencies also and settling disputes also, there's a robust system in place. So all of this put together, what I am pointing to is that for companies in niche areas also, in semiconductor fabrication, in packaging, in IoT devices, we have huge market. For example, we have a smart city project. So where there's deployment of lots of sensors and IoT devices happening in the country, in 100 smart cities. And preference is given to those companies which are making it in India. So all of this is contributing to a hugely enabling environment, and we would welcome all the companies to look at India very seriously. Please get in touch with us. I will share my email ID, the ones from the Invest India also, and we look forward to partnering with each of you. One last thing from my side, like Ritu Parna ji talked about, or before that, Mr. Rajiv Kushu talked about presence of TI, of MediaTek, of design in India, and the chips which are coming. My request is today there is growing appetite of Indian champions also. Indian mobile companies, Indian IT companies, they are hungry for chipsets. So more and more allocation should happen to Indian companies also. While we take it at different fora, we are looking at some kind of shortage of semiconductor chips, largely in logic segments and in the emerging technologies in AI, IoT based applications, and some part of it in power and the logic part also. We would request, for example, company like MediaTek, we would want MediaTek operations not just from design part, but also from the chip usage part for Indian companies to increase. Similarly for TI and so on and so forth. And we welcome them to allocate chipsets for Indian markets and for Indian manufacturers also. Thank you.
Thank you. Thank you for your very informative sharing. I guess if I may, I could summary for some highlight and also, but of course, I think we have to explore more further in the future for further detail. Okay. I think to the Taiwan company or any company they want to invest in India, I think Indian government, they got like some regulation or some help services for like Taiwan desk. You just mentioned that. So it means if the Taiwanese company, they want to invest in India, perhaps they can get some services such as like coaching service. Okay, so give them some information to help them to do some like registration or anything doing the business there, as well as some of the cluster building up. So like you mentioned that you got like 26 or electronics manufacturing cluster. So a lot of the Taiwanese companies, you can look into it and to see whether you can find some opportunity or take some advantages on that to build up your investment or your business in India. And also, you mentioned that some facilities coming to India, you can receive some of the help from the government for their services, as well as you mentioned that regarding the taxation. So you got a unique GST for those investment in India. Of course, there's some complicated some integration. Maybe we can explore in the future for further details. So, and also some of the industry park, like you just mentioned in Bangalore and in Delhi, and you have some land, some service park there as well. I think all of that information we can share in the future with our Taiwanese companies, and also, I guess some information we can also take some help from the ITA in Taiwan. They also got some information anyway, I think. So thank you for your sharing, Mr. Go. I think it's very valuable to Taiwanese company, especially to today's our topic about a semiconductor. I think in the future, we are not just silicon handshake. I think maybe we can brace together, I think, right? So we have ever since last year, we have a lot of discussion. I think in the future, we can embrace together and join together for a lot of the business in the future. All right, I think although I still got a lot of the questions from the audience, but I don't, I think we just run out of time. I don't really want to close, but it looks we are run out of the time. I have to wrap up right now today. So again, thank you all the panelists today to join me in this fruitful discussion. Now allow me to wrap up program today. And it is indeed, there are huge potential for India, Taiwan to cooperate together, especially consider our speaker and our panelists mentioned that the complementary of industry strength and advantages for both Taiwan and India, and the potential market demand in India. Okay, after the post COVID-19 pandemic, the market will be growing again. Therefore, forming technology alliance the post-pandemic between Taiwan and India is a very key topic worth us to explore further in the future. So let's go silicon handshake. And I think in the future, we can brace together and join the business together. Again, thank you all the forum participants today and online audiences. Especially, I want to express my apology to the online audiences. I cannot raise any of their questions because we are running out of time. We look forward to seeing you soon again in the future. Until then, stay safe and all the best. I wish you all the best and have a very good day. Okay, thank you. Goodbye. Thank you all.
Thank you.
Bye-bye.
Thank you. Bye-bye.
Thank you, Dennis Fu, and thank you to all our speakers and panelists. Please be reminded that we have made a recording of this forum and will post it on our social media platform. Our Facebook link is also in the video description. We'll be sending out the feedback form today. Please take a few short minutes to fill it out. Your feedback is very important to us. Thanks again for joining us today. We'll see you next time. Bye, everyone.